dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Welcome back our students. So I'm teacher Abdulrahman Musa Ismail, chemistry teacher. As you can see here, this is our exam schedule, particularly third term cycle 2 examination. So in chemistry, you will do chemistry 10 June. It's a Wednesday, so you can consider this schedule. Again, from Forest, welcome. So we want to continue our lesson list. So last class we did what we call video lesson number 6. So this video lesson number 7. So we shall continue our lesson. So we were in organic chemistry. It was chapter 5. It was the last chapter. So we came across what we call alkanes. Again, properties of alkanes, uses of alkanes, nomenclature of alkanes. So for today, we want to continue what we call isomers. So isomers are general. We are not going to do only isomers of alkanes, but this class we want to do isomers in general. Isomers of alkanes, say alkanes, alcohols, or families. So this is what we call isomers. So here you see all types of isomerism. So I can use this isomerism or I can use isomers. So when I say isomerism, it is a kind of process or it's a kind of reaction. But when I say isomers, it is a name. So we want to do isomers. So all types of isomerism, or we can say all types of isomers, are shown in this figure below in a form of family tree, in a form of what would be called concept. So we have here concept map. So you can consider the types of isomerism, the types of isomers. So here we have isomer, or say isomers or isomerism. So there are two main types of isomers. Number one, we can say structural isomerism or structure isomers. Number two, we can say stereoisomers, what we call three-dimensional isomers. So stereoisomers are always called three-dimensional isomers. Here we have structure isomers. We can classify structural isomers into three. What are they? Say functional group isomers, chain isomers, and positional isomers. So in here you have in here we have positional isomers and functional group isomers. These two are very similar, positional isomers and functional group isomers. So we can take two instead of saying three. For example, we can classify structural isomers as chain isomers and positional, or you can use chain isomers and functional group isomers. Since these two are very similar, say positional isomers are functional group isomers. So these are the types of what we call structural isomers. What about stereoisomers? Stereoisomers we can classify into what? Geometrical isomers. Again, we can say optical isomers. These are the main types of what stereoisomers or three-dimensional isomers. We can classify what we call geometric isomers, cis-trans isomers. This is one kind. The other one is called ether isomers. So we shall see all this. Okay, we want to start structural isomers. So structural isomers are under what? Structural isomers are under isomers. So we want to define structural isomers. What are they? How can I define structural isomers? Structural isomers are isomers of what? When I say isomers, it is a kind of plural. They contain two or more. We can't say one. They are always plural. So isomers are always what? Compounds which are similar. Similar in what? They have a same molecular formula but different structural formula. So here we have they are isomers are molecules, say are compounds which have same molecular formula but different structures. These are called what we call structural isomers. So structural isomers are compounds. Number one, they are compounds. So these compounds, there are two or more compounds which have what? Same molecular formula. We came across this kind of formula. Molecular formula, for example, molecular formula of say benzene. Molecular formula of benzene, it is like 5, say 12. This kind of formula is called a molecular formula. What about the structure? Structure, we can say structural formula, say we can say displayed formula. So we can say expanded formula or condensed structure formula. So this is structural formula. So the structural formula of benzene, we can rewrite it. So compounds which have the same molecular formula but different structures are called structural isomers. These are called structural isomers. So structural isomers or isomerism occurs when the atom is in a molecule, or when the atom is in a molecule, a single molecule can be bonded in a different ways. For example, benzene we can draw in a different structure. Benzene we can draw in a different structure to produce distinctively different compounds. For example, benzene, it contains C5H12. So we can arrange in different ways around, say, three different isomers. So these three are called structural isomers. Again, structural isomers we can classify into what? Into two. Number one, say chain isomers. The other one is called positional isomers. Chain isomers and positional isomers. When I say positional isomers, we can also call functional group isomers. Functional group of isomers. Okay, if you consider here, here we have what we call C4H10, and here I have what we call C4H10. So these are two compounds. They have the same molecular formula, equal molecular formula. Here you can see C4H10, say C4H10. So C4H10 equals C4H10. So they have the same molecular formula. But I can draw in a different ways. So they have a different structure. They have a what? Different structure. For example, this one, I can write 1, 2, 3, 4. For example, this is a butane. So I can say 1. So these are single bonds. If it is an alkene, we can say single bonds between all atoms. So here we have hydrogen, here we have hydrogen, here we have hydrogen, here we have hydrogen. Say hydrogen, hydrogen, say hydrogen, 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 hydrogen. So the name of this compound is called butane. This is called butane. What about this one? For example, this contains what? We can arrange in a different way. Structure which is very different this one. For example, I can say 1, 2, 3. The number of carbons is the same. Consider this one 1, 2, 3, 4, and here 1, 2, 3, 4. You see, this is a linear. The number of carbons are linear, but here we have a branched one. So again, the bonds are all bonds in between these are single bonds. So single bonds between all atoms. Say single bond between all atoms. Every carbon should have what? 4 single covalent bonds. 4 single covalent bonds. So here you have what? Okay, consider this one. So if you count, even the number of hydrogen atoms attached to this number of carbons are 10. Here you have 10 hydrogens, here you have 10 hydrogens. Here you have 4 carbons, here you have 4 carbons. But the structure is not the same. So they have the same molecular formula, but different structures. I can say equal molecular formula, unequal what? Displayed formula, structural formula. So these compounds are called what? Isomers. So this is called butane. What about this one? If you consider this one, it is C1H3. This is called 2-methyl. Say propane. This is 2-methyl propane. So 2-methyl propane is isomer of butane. So I can say isobutane. It looks like butane, but it's not a butane. So 2-methyl propane, again butane, there are two compounds. These are two compounds. So they have the same molecular formula, but different structures. So compounds which have the same molecular formula, again have a different structures or different displayed formula, are called isomers. Isomers. Which kind of isomers? Structural isomers, because they are different. The structure. Their differences are what? In between their structure. Consider this example. We have seen this example. Again, here you see the structure. If we count this number of carbons, here you have what? Here we have 1, 2, 3, 4. Say this is butane. We have seen this example before. This is butane, C4H10. What about this one? 1, 2, 3. So this is a propane, and this is a methyl group, and this is a methyl group. So if I try to write the molecular formula of this one is C4H10. So C4H10 equals C4H10. But these two structures are very different. These two structures are what? Very different. You can consider this one it's a kind of linear structure, but this is a branched structure. So 2-methyl propane is the isomer of butane. It's the isomer of butane. So they have a same molecular formula but different structures. So these two are alkanes. Both of them are what? Alkanes. What about here? Here we have what we call ethanol. Here we have what we call ethanol, and here we have mixed methane. It is a kind of ether. This is an alcohol. This is an ether, not ester. Ether. This is an ether. It contains what? 2 carbons, 1 oxygen, and 6 hydrogens. Again, if you consider this one, 2 carbons, 1 oxygen, and 6 hydrogens. So they have a same molecular formula. If you want to write this one, the number of carbons are what? This contains 2 carbons, 6 hydrogens, and 1 oxygen. What about this one? This contains carbon, hydrogen, and oxygen. Say 2, 6. So I can say C2H6O1 is the same as C2H6O1. So they have the same molecular formula but different structures. But the structure, the arrangement is different. You see, these two are in different families. One is called ether. One is called family called ether. The other one is called family called alcohol. Family called what? Alcohol. But they have a same molecular formula but different structures. So these are called what? Structural isomers. Structural isomers. What about here? What about here? Here we have what? Here we have positional isomers. What are positional isomers? So positional isomers refers to molecules with the same functional group. Sometimes we can call positional isomers or functional group isomers. It is the same. So don't be confused. This functional group isomers. So positional isomers refer to molecules with the same functional group is attached in a different positions. So when the functional group is attached in a different position, we can simply say that's a different isomer. On the same carbon chain. When the number of carbons is the same, So if you consider here, 1, 2, 3. Again, 1, 2, 3. For example, I want to write here. We have 1, 2, 3. We have a chain or number of carbons. A chain carbon containing 3. So this is a kind of what we call alcohol family. So alcohols, or the functional group of alcohols, is what? OH. We have seen this one when we have studied this lesson, not this lesson, the previous lesson. So this is what we call alcohol, because it contains carbon. Again, it's attached to OH group. This time the OH group is attached to carbon number 2. Here we have another molecule. So this molecule, the OH group is attached to what? Carbon number 1. The OH group is attached to what? Carbon number 1. So when the OH group is attached to carbon number 1, again when the OH group is attached to carbon number 2, so the name is different. So I want to mention here. Okay, I want to write this one in a form of molecule. In a form of what? Molecular formula. This is C3H7. Again, this is what we call C3H7. What is the functional group of alcohols? It is OH. Functional group of OH. So these two are very similar. They are the same. So you can't mention whether this is proba 1 all or proba 2 all. You can't mention it when it's written in the form of molecular formula. So what is the difference? We have to draw this. So it contains 3 carbons. Say 1, 2, 3. Again, this contains 1, 2, 3. So both of them contains 3 carbons. For example, this one, the OH group is attached carbon number 1, and here the OH group is attached carbon number 2. For you to mention the name at this time, it is easy. So you can simply say what? When the OH group is attached carbon number 1, you can simply say this is called prop. Say prop 1 all. What about this one? The OH group is attached carbon number 2, so you can simply say what? Prop say 2 all. Prop 2 all. So prop 1 all is not the same as prop 2 all. So what is the difference between these two molecules? They have a what? Same molecular formula. They have a same molecular formula, but different position of the functional group. So when the functional group is attached in a different position, you can simply say positional isomers. You can simply say what? Positional isomers. So this kind of isomers are called positional isomers. This kind of isomers are called what? Positional isomers. Positional isomers. We can mention another two. We can mention another two. For example, this is called alkene. This is called alkene. So this kind of alkene, so I want to write here. Okay, go to here. So I have here, this is called C4H8. Again, this is called what? C4H8. C4H8. This is called butene. Both of them are butene. Both of them are what? Butene. So they have a same molecular formula. Same molecular formula. But in here, for you to draw this one, it is, for example, 1, 2, 3, 4. So the double bond is here. It is an example. What about here? 1, 2, 3, 4. So the double bond is here. What about here? For you to mention the name of this one is what? 1, 2, 3. So the double bond is attached to carbon number 1. For example, this is carbon number 1, 2, 3, 4. And here is 1, 2, 3, 4. So the double bond is in between carbon number 1 and 2. For you to name it, you have to mention the smaller number. So it is in between 1 and 2, so you have to mention 1. If it is in between 2 and 3, you have to mention 2. At this time, I can say but. I can say what? But. The double bond is attached to carbon number 1. Then you can say in. In is the double bond, which means but 1 in. You have but means 4. You have 4 carbons. Again, carbon number 1 is attached double bond. So but 1 in means like this. So but means 4. You have we have a carbon and 4 carbon atoms. Again, these 4 carbon atoms, carbon number 1. This is 1 is attached double bond. In means double bond. What about here? How many carbons? We have 4. So you can say but. We have what? But. These 4 carbon atoms, carbon number 2 is attached to double bond. So you can say 2, then in. In means double bond. Then this is in means what? Double bond. In means double bond. So the double bond is attached to carbon number 2. The total number of carbons you have is 4, which means buta. Double bond again is in. So the double bond is attached to carbon number 1. Then how many carbons you have? Buta means 4. So they have what? They have what? Same molecular formula. But the functional group, at this time, our functional group is what? If it is an alkene, the functional group is double bond. So the position of functional group, the position of the double bond is different. If you compare these two molecules, this one, the double bond is attached to carbon number 1, and here is attached to carbon number 2. So when you have two molecules which have a similar number of carbons or same number of carbons, and the functional group is attached in a different position, it is called positional isomers. These are called what? Positional isomers. So here you have what? Proba 1 all, and here you have what? Proba 2 all, which means the OH group is attached to carbon number 1, the OH group is attached to carbon number 2. So we can simply say positional isomers or functional group isomers. They are the same, so don't be confused. Okay, here we have another example. You might see this example. We are talking about this example. So see this example where positional isomerism and chain isomerism, these are both. This example, you see, if you consider here, so ignore this part first. Ignore this part. The OH group, we don't want to mention that one. So first step, we have to compare these two at the side of chain isomeres. So how many carbons we have? We have 1, 2, 3, 4, and 1 branched carbon. Here you have 1, 2, 3, 4, 5. So this is a chain. Again, this is a branched. So you can say what? They have a same molecular formula but different structure. So this is a chain. At this time it is a chain isomer. What about if you consider the OH group? At this time the OH group is attached to carbon number 1. What about here? What about here? You don't have OH group. You don't have what? OH group. So this example indicates you what? It's an example where the positional isomerism and chain isomerism are present. So we came across what we call chain isomerism, positional isomerism. Chain isomerism and positional isomerism, both of them are what? Structural isomers. So we want to start the other type, which is stereoisomers. So stereoisomers are under what? What we call we have stereoisomers. Under stereoisomers we have what we call optical isomers. So this is not our specification. The other thing is what we call cis trans isomers and EZ isomers. So consider here. So we want to do this one. What is geometric isomers? Or the geometric isomers. Under geometric isomers we have cis trans isomers and what we call EZ isomers. So EZ isomers is very similar to what cis trans isomers. So geometric isomers are 2 or more compounds. They contain 2 or more. They contain what? 2 or more, which differ from each other. They are different from each other. We know the differences in between chain isomers, positional isomers. So consider these differences in the arrangement of what groups, with the respect of what? Double bond. So if it is EZ isomers or geometrical isomers, they should contain double bond. Or the molecule should be unsaturated. Or the molecule should be what? Unsaturated. So they are also called cis trans isomers. Okay, consider here. We have here what we call butene. If you consider this one, we have butene. If you start carbon number 1 here, and this is carbon number 1, say 2, 3, 4. What about this one? 1, 2, 3, 4. We have 4 carboatoms. So these 4 carboatoms, if you want to name, both of them are what? Butene. So ignore this one. We don't know at this time. Ignore this one. So what is the name? What is the correct name of this one? I can simply say but. 2-ene. What about this one? We can say but, say 2-ene. So both of them are but-2-ene. So both of them are but-2-ene. So do we have any difference in between these two molecules? Yes. So consider these arrangements. What about here you have what? Carbon double bond carbon, and here you have what? Carbon double bond carbon. So carbon double bond carbon and carbon double bond carbon. So that's our base. So methyl group is on the same side of double bond. If you consider this base, so our base is what? Carbon double bond carbon. So how many species are attached to this base? It's attached what we call methyl group, and here is attached methyl group, here is attached hydrogen, here is attached hydrogen. So consider the methyl group is attached to your base. So the base is carbon double bond carbon. The methyl group is on the same side. If these methyl groups are on the same side, you can say below the double bond or below the base or above the base. You can simply say what? What we call? You can simply say what? It is cis. If they attach, for example, first you have to identify the base. When you identify the base, how many species are attached to this base? 4 species are attached. Consider the other species rather than the hydrogen. So which are they? This is methyl group, this is methyl group. So do they have on the same side? For example, do they below the base or above the base? If they are below the base or above the base in the same side on the same side, so you can simply say what cis. This cis 2-butene. What about this one? Identify the base. You have identified the base. Consider the substituents, what we call methyl group. So here you have methyl group and here you have methyl group. So methyl group is on opposite sides. At this time it is opposite. What about the previous one? They were same side. So these methyl groups are opposite sides. When they are opposite sides, you can use trans. You can use what? Trans. So this is called cis-butane, and this is trans-butane. So they are only different. That the group is that's attached to your base. At this time they are opposite. What about here? They are in the same side, whether they are above the base or below the base. What about here? This is another name, call it EZ isomers. So Z means susamen, which is together. E means ingaton, which is opposite. So this EZ isomers is better than cis and trans because of what? If it is a cis and trans, the species which are attached to your base should be similar. Should be what? Similar. For example, methyl group. Well, here you have methyl group, but cis and trans should be what? Different. For example, we can put here hydrogen. You can put here what we call fluorine. For example, what we call fluorine. Again, cancel this one. You can write what we call chlorine. For example, here you have chlorine, hydrogen, fluorine, and methyl group. So at this time you can't say cis or trans. You can't say cis or trans. So what are you going to do? You have to identify the mass number of these species. For example, chlorine. The mass of chlorine is what? 35.5. The mass of chlorine. What about hydrogen? Hydrogen is 1. What about fluorine? Fluorine is 19. Fluorine is what? 19. What about methyl group? Carbon is 12, hydrogen is 3. So add together, this is what we call 15. Then you have to identify which species have the highest mass. Which 2 species attached to your base. This is your base. So here we have the base. So how many species are attached to this base? Chlorine, hydrogen, fluorine, and methyl group. Again, when you do this one, again you have to identify which 2 species attached to this base have the highest mass. So number 1 is chlorine, which is 35.5. The other one is it 15 or 19? So it's 19. So you can compare these 2. When you compare these 2, for example, this is 19, again this is 35.5, do they have on the same side? No, at this time it is opposite. If it is opposite, you have to say E. So this is E isomer. Are we together? What about if fluorine and chlorine should attach it on the same side? It's supposed to be susamen. It's supposed to be what? Susamen. So EZ isomers is better than what? Cis-trans isomers. So it works even the species are different. Even the species are what? Different. At this time we have what? Methyl group, hydrogen. If you identify which 2 species have highest masses, for example, methyl and methyl, they have the highest masses. When they have highest masses, so you can compare. Should I say intergon or should I say susamen? It's supposed to be what? E. What about this one? They have a what? On the same side, so you have to say susamen. So this is called EZ isomers and this is called what? Cis-trans isomers. Both of them are under what? Geometric isomers. So my students, we have to finish our lesson here. Thank you very much.